We've got something new for you here. We're doing emergent behavior. These are our live product demos. This is a new experiment for Cerebral Valley. So first up, we have Chelsea Finn with physical intelligence. So we are going to dive into the world of robotics, somewhere we haven't really dug in so far today. A very exciting company, and you're going to get to see the software powering robots in action. So Chelsea, you want to come up here?
Hi everyone, my name is Chelsea. I'm a co-founder of Physical Intelligence. I'm also a professor at Stanford. At Physical Intelligence, or PI, we're training robots to do lots of different things. And one of the things that we trained one of our robots to do is to unload and fold laundry. So this is a video that we released just 3 weeks ago. The robot here is fully autonomous with no teleoperation, and it's able to unload multiple items out of the dryer and then go fold all of those items, again, fully autonomously without teleoperation. This is really, really hard to do. The reason why this is really hard to do, and this is, in my mind, I've been working in robotics for a while, this is one of the most impressive things I've seen a robot do. The reason why this is hard, first, is very long. The robot has to not make mistakes, or at least recover from any mistakes that it makes, and it has to not get stuck in order to complete the full sequence, which it does in just 10 minutes. And the second reason why it's hard is that it has to perform very dexterous maneuvers in order to handle the variability that these different clothing items will present it. So it followed the first two shorts here. It does make mistakes, but it's able to eventually recover from them and be able to flatten items, fold them, and so forth. Here's the third shirt. The other thing that's really challenging about this is that you have to handle a lot of variability. So shirts and shorts can be crumpled in many different ways, and the robot has to be able to react and be able to intelligently understand what to do in all those different circumstances. So now, in my mind, this is really exciting. It's pretty cool to see a robot do laundry, but actually, the reason why this is exciting isn't because it's doing laundry. The reason why it's exciting is the recipe and the broader problem that it's working towards. So the broader problem is that if you want to actually truly address an application in robotics, you essentially need to build an entire company around it. You need to build one company for being able to move packages around, or a company for wet lab automation, or a different company for cooking, or a different company for surgical robots. And it's really, really hard to address robotics applications truly, because for each of these applications, you need to, on top of building the hardware, develop custom software, design unique movement primitives for handling the different scenarios that robot application might require, and also understand the edge cases, and so on. You have to do all of this from scratch. And this is the broader problem that we're aiming to address at Physical Intelligence. We're interested in understanding whether we can build a general purpose brain that can enable any robot to do any task. And we think that this sort of approach will be more successful than trying to address one particular application, just like we've seen in other areas of AI. And so now going back to the laundry, what's exciting is that it wasn't actually just a robot that's trained to do laundry. It's actually a general purpose model using a pre-trained language model with a vision encoder, pre-trained on internet data, trained on 10,000 hours of data that we collected in our office, and trained to do many different tasks, such as the one shown on the right, including the laundry that I showed before. And so, for example, an example of a few of these tasks, this model can power a different robot, in this case a UR5 robot, to clean a table, including being able to put novel objects into the garbage can and put dishware into the bin. It can also power a completely different robot to scoop coffee beans into a coffee grinder. This task is pretty challenging because you need to fairly delicately pick up the scooper and use it to scoop items into the coffee grinder. The same model can be used to power a third robot or a fourth robot, if you include the laundry one, to be able to move food into a takeout container. And then one last example is it even powers the robot to do a very challenging task of constructing the bottom part of a cardboard box. And this task is really challenging because you have to fairly delicately perform each step of the task, and you need to perform a number of different tasks to get the box into the place, and then fold each of the flaps and secure them into the box so that it stays constructed. So these are just a few examples of the robots that our model can control and the tasks that it's able to do on those robots. These are all robots in our office, and we can also actually control robots from other companies as well. So this is actually a robot from the company called Astrobot. And I've actually never seen this robot in person before. And I also don't know actually that many details about how it's controlled, but we don't actually need to know that. So Astrobot sent us some data from our robot. We fine-tuned our model on that data, and this is a video of our model controlling their robot, in this case, to make coffee. Because the robot was pre-trained on lots of data and is trained on data to perform this particular task, it can also react to different scenarios. So in this case, it's able to do the task with multiple different cups. And it's also able to react if a human messes with it. For example, if a human takes something out of the robot's gripper, it's able to continue to do the task and recover. So those are a few examples of what our model is able to do so far. This is really just the beginning. We're a company that was founded 8 months ago, and we really believe in a future where kind of the next generation of robots will be powered by a single general purpose model that has physical intelligence. Thank you.
Wow. I feel like, a lot of times in Silicon Valley, we're like, oh, we're not inventing the world of, sci-fi that we hope for. And I think that's a presentation where it truly is delivering all that we imagine Silicon Valley can be. So really, really impressive. Moving to our next presentation, we have Wasim Al-Sheikh, the CTO at Writer, who's going to show us their latest developments and cool LLM tech. Take it away.
Hi, everyone. Excited to be here. My name is Wasim Al-Sheikh. I'm a CTO and co-founder of Writers. Writer is a full-stack platform for enterprise. We combine large language models with a graph-based implementation, including AI guardrails, with a suite of tools for developers to help enterprise build their AI workflow. We work closely with some of the largest enterprises in the world today, like Vanguard or Salesforce, and we power their AI application. The story of Writers, the way we love to think about the story of not just enterprise SaaS, is the story of innovation. For the last few years, we built dozens and dozens of new models since 2020. We developed a lot of new method of training and a lot of new wide research we published today, and including one of the best domain-specific model in the industry, specifically in medical and financial services. Now, I believe most of you are aware with all the talk about hitting the scale or limitation, how much we can scale large language models. And this is something we start noticing early 2024. And basically, there is no longer basically expect to add more parameter, more data, and you're going to get just better result. And we start seeing a lot of amazing innovation around it. People start basically thinking how we can scale the inference side like we see existing model today. The way we start thinking about it from a writer side was, I believe, what we actually, if we can make the model itself think differently. Why we don't actually not just increase the inference side, we look at the model and give them memory. Memory and what we call it self-eval. Basically, us as a human, the difference between who we see in the simplified way, expert and non-expert, it's the experience, it's the learning. You see stuff, you learn from your mistake, you don't do it again, you reflect on it, you take this learning, and next time you're facing the same issue, you just keep building on top of it. What if you can do the same thing? What if the LLM actually can reflect, evaluate this knowledge, remember the knowledge? This is what we actually announcing today. It's called self-evaluation models. Self-evaluation model meaning those models can actually learn on their own. Those models can learn in real time. Those models also can reflect on the learning. It's not just database when you can take whatever information. You can look at the information, evaluate if actually existing learning exists, and reflect and remember it without any external sources. Basically, the vision and what we start seeing in those models, if you use a model more and more uses it, you get just more knowledge, more better implementation. I'm already almost 4 minutes in, so I don't have basically too much time to explain it, but in a high level, the way we think implementation or what we look for architectures, we build what we call memory pool with each transformer layers, decoder only implementation, just to be clear. And basically this memory pool, we could be updated in real time based on reflection. This is more high level. We publish full blog posts in the details explaining how each step works, and we have a live demo today we'll show you pretty quick. But basically, to summarize, in each layer in the transformer, say we have a model in 40 or 80 layers, those models will take their own actually memory pool, and this memory pool can maintain those tokens, and you can update it real time. When you have a new update, this update will show up there, we'll take the old tokenizing, score it, merge it, refresh the memory pool, and add it back. To do that, basically, the model not just need memory pool, also need a way to actually reflect on the behavior. We have something very quick, actually, demo here to show you guys. We'll get this one. Basically, if you look at this, we're going to run a very, very simple demo. You're going to notice two things. Clear the conversation, it's just cleaning the history, the context window, but we have something very important here, what we call the model weight reset. Because again, we're adding knowledge to the model directly. It's not a database, it's not a context window. If we take something simple in this design, let's say ask question, and keep in mind, by the way, this is 8 billion size model, is very small for demonstration. And let's ask something like, basically, which country has the largest population? And here you go, we get the answer, right? Cool. There's one issue with the answer, right? It's wrong. I really want to actually reflect on the right side. There you're going to see a bunch of parameters. The most important one is reflection and what we call the updated trigger. So the model now just took into the conversation, nothing happening yet. So let's actually tell the model wrong. And let's just give them one word. Actually, India is the largest population. Nothing else, no context. So what happened basically is apologize, very polite, perfect. The right side is the most important thing. What's happening, if you can see it, hard for me to see it from here, the model reflect on the conversation, figure out what's new, what's wrong, and say, you know what, this actually, I made mistake. Let me take it back, let me evaluate it, let me update it. Means if I went back here, and I said, let's clear the whole conversation, and ask the question again. Give me the correct answer. So this is cool. You can do that with multiple things. But what if you actually run the whole thing at larger scale? What if you say, this is cool. I want now to do it differently. I want to run it in a full data set. We done that. It's going to take up more than actually 5 minutes to do it. We run this actually models and standard math, benchmark, GSM-K, standard implementation, and also reasoning. And this is the fascinating part. With this benchmark, we did not tell the models the answer or the correct answer, or what we say, correct or wrong. What's happening first round, as you can see, for example, in math, below 25%. Second round, by just telling the model, you give me wrong answer, we don't give the correct answer, the model actually learned. With the next round, the model tries something else. It's jumping to almost 50. Third round, actually stuff started going to around 65%. So start basically get fascinating that you see this model actually learning in real time, maintaining the knowledge and doing it. And if you can do it in this way, you don't need just a human. What will actually happen if you get the model to learn from a web data? Let's put it there, let it learn. And this is what's fascinating, start happening there. In model, basically, when you run it, we have something here called the RG score. If you guys are not familiar with it, it's basically the safety score or how much the model actually following the guardrails during the post-training implementation. With the human, we did not see any change. Opening the model to the web, less than 24 hours. Very troubling result there, 21%. It's exciting at the same time because now we know self-eval technique in the transformer model, and not just give it real-time training, but also the model start figuring out how it censor himself, how you actually have some kind of freedom with answering the questions. Now, we know this is challenging and troubling. We're keeping today those models for limited access writers. This is going to require completely different implementation from safety and security side. Those kind of models cannot follow just normal or standard implementation from guardrails. It's going to require a completely different protocol and measurement to ensure self-involved models can actually use in a confident way, in a safe way. Now, to read more about this, we publish about it today at Writer website. Feel free to scan the QR code to get the details. Thank you so much, guys.
Wasim, thank you so much. Self-improving models. Now, an exciting presentation from Useful Sensors. We have Pete Warden and Jacqueline Cervantes. We're going to give them a second to get set up.
Hola, buenas tardes. Mi nombre es Jacqueline Cervantes y soy la directora de ventas en Useful Sensors. Y me da mucho gusto estar aquí con ustedes para poder platicarles un poco sobre nuestra tecnología llamada Torre o Torre en español. Torre es un dispositivo que mantiene tus conversaciones privadas y seguras sin jamás tener que conectarse al internet. Me recuerda mucho a cuando yo era pequeña, tenía que acompañar a mi mamá a sus citas al doctor, al banco, con mis maestros y a cualquier lugar y ser su traductora. Las conversaciones nunca fueron fáciles de navegar, pero tenía que ser su traductora. Ahora, familiares de personas que no hablan inglés no tendrán que asistir con ellos a cualquier cita. Las personas y empresas podrán usar Torre para hacer traducciones en tiempo real y podemos ver cómo personas pueden transformar la manera de comunicarse y conectar con los demás. Aquí Pete, el co-founder y CEO de Useful, les podrá dar un poco más de explicación sobre nuestra tecnología.
Awesome. Thank you so much for the Spanish there, Jackie. And I hope you'll forgive the occasional typos. As you can imagine, this is quite a challenging environment for speech to text engine. But what you're seeing right now is Torre, our instant language translation product. And not only is it fast, we've designed it so that you can actually have a conversation in Spanish as easily as watching a foreign language movie with subtitles. And not only is it running with really low latency, it's actually running entirely locally. So everything is running on device, which means your conversations are completely private with no internet connection. And that also means that you can set it up anywhere in the world with no initialization or accounts or anything else required. Now, what we found is that the speed and quality that we're able to achieve has already had a big impact in the places where we've been starting to deploy this. The sort of places that Jackie talked about, sort of doctor's offices, anywhere where there's a lot of people who don't speak Spanish, who have to work with a lot of Spanish speakers. And I really love the fact that for people like me who struggle with Spanish, it lets me connect with people who are native Spanish speakers. But more than that, it really unlocks so much potential because there are so many people who have been stopped by language barriers from actually sharing their skills with other people. So I love the fact that we are able to unlock a lot of potential out there in the world. Now, this is just the tip of the iceberg of what's actually possible, though. I just realized I should be holding this closer. So the product is built on top of Moonshine, which is our speech-to-text engine, which is... So I realized I forgot to switch from Spanish translation. It was spending all of its time actually trying to translate from what it thought was Spanish into... So this is actually working a lot better, thank goodness. I just try to keep you all on your toes. So really, this is just the tip of the iceberg of what's possible using voice. I think as the earlier voice panel actually discussed, it's such a natural way to interact with LLMs using speech-to-text technology. And we've built this on top of Moonshine, which is our own speech-to-text model, foundation model that we've trained from scratch, which is the same accuracy as Whisper, which hopefully you can actually see now that I've got it in the right language, but is 5 times faster. So that actually gives us the latency that we need to really be able to offer that kind of user experience that comes when you're able to run stuff really, really fast. And we've open sourced this model, so you don't just have to take my word for it. You can actually go to our GitHub or Hugging Face and actually give it a try and tell us what you think. So up until now, the only solutions for this kind of voice interface have been using Whisper or using some kind of proprietary or OS level kind of integration. What we're really aiming for is Moonshine lets you integrate a fast and responsive speech-to-text system with your application. And we're actually even able to run in the browser locally, so you don't need to even make any changes to your server code or your models. You can make it as simple as just adding a little JavaScript script tag to turn your text input into a speech input. Now, obviously, things can get a lot more exciting once you can do deeper integration, but you can get started very, very easily. And I'm so excited about this because what we're doing really gives us a chance to bring AI out from behind screens and actually move it into the real world with us. Removing language barriers is just the beginning. Imagine what we can do as we teach AI models to really understand us in the way that we want to express ourselves. So I'd love to chat more about what's possible. So please come and find us later in the afternoon, and we can geek out and give you a demo. And thanks so much.
Pete and Jacqueline, thank you so much. Language is another one of these things where it felt like, oh, we worked on it for years and years and years, and now suddenly it is possible to do this real-time translation. So pretty amazing stuff. Excited to welcome to the stage Infinity AI co-founder Lena Colucci. I think we're gonna see some fun character-based videos, so some AI video creations coming up next, and it'll take 1 second to get set up.
I remember my first time trying to make an AI film. You'll see in a second behind me the clip that is actually part of that film, and I'll be honest, it was really bad. But it didn't matter because from that moment on, I was hooked on making these AI movies. All of a sudden, I could go from ideas in my head to something that I could show people like that. Can we get the projector? It's coming. And so, as I got into making more and more of these AI films, I realized that they kept falling short of what I really had in my head. And I realized that's because AI models were not optimized for people and for character creation. Essentially, when I tried to make characters, I couldn't make my main character look the same from scene to scene. I couldn't control their expressiveness. And I couldn't even make them talk. Like, the video models couldn't do that. And so I said, hey, why don't we just make our own? And so at Infinity, we've trained our own video foundation model focused exclusively on people and characters. These are some clips that our users have made using our proprietary model. These are all AI generated. And our focus is allowing people to make expressive characters that can actually speak, because characters are really what captures our hearts, it's what makes us connect to content. And what I thought would be cool to do today is to have us make a video together right now in real time. This is one of my favorite things to do, is just make stuff with other people. And so if you guys will indulge me, it will require a little bit of audience participation. All right, so I am on the Infinity Studio. This is studio.infinity.ai. And it's really easy to make a video. We just pick an image, we pick our audio, and then we press generate. And I thought it'd be fun to make a video of Alex Wang, the first speaker today. And it's gonna be, what I would love your help with is figuring out what we should have Alex say. And it's super easy to type out a script and then generate the audio right here. I wanted to do this in a Mad Lib style though. And so I'm gonna ask AV to turn off the projection for a second, because I'm gonna ask you guys for words and you're not gonna see what the script is until we kind of see it at the end. So can someone please give me an adjective? Happy, great. And an animal? Let me type and talk here. How about a monument? Mount Rushmore. And a famous company. Facebook. Great, thank you guys. 1 second here. All right, and AV can turn that back on in a second, whenever you guys are ready. And then the other thing is, let's figure out, so I generated this audio, it's 14 seconds here. Let's figure out what image we want for Alex. And I think it'd be fun to turn him into a cartoon. So we can do a 3D Pixar style man, and then let's put him in front of our monument. So Mount Rushmore in the background. And we'll do a close-up portrait. Let's try this out. All right, pretty good, we'll go with it. And so there's all sorts of different video generation parameters here. And once we press generate, it will appear in our queue. Let me just refresh to make sure that is indeed going to happen. Okay, there we go. I generated two. So while we're waiting for that to generate, it'll just take a second. I wanted to show some of the cool videos that our users make using Infinity. So one of my favorites is educational content.
Greetings, fellow tiny humans. Welcome to Quantum Qualos. Knowledge. Like this rattle?
So in addition to being really cute, in this case, it's basically babies teaching quantum physics. So pretty cool. I like this ad over here.
Stop scrolling. You need to know about this skincare secret, Embryo Lease Cream. I know. You've seen this cream.
So the thing I like here is you could make this same ad without a person in it, just with a voiceover, but it's so much more engaging to have the human there, and it's so easy to do it now with Infinity. So let's check back on here and see how we're doing. Great, our videos are here, they are live. And this is always the nerve-wracking part about live creating is I have no idea what this is gonna look like. One thing I should clarify though is that our model has not been trained on Alex, it has not been fine-tuned on Alex. All we needed to do was just give it a photo. So you could actually do this yourselves afterwards on the Infinity Studio. All right, so should we play it? All right, so this is an alternate universe in which Alex is not the founder of Scale. He started a different company, so let's see.
I am the founder of a company called Happy Red Panda. Every day I stand on the corner of the Mount Rushmore and tell people if their object is a hot dog or not a hot dog. It's very profitable, and someday, Happy Red Panda is going to be bigger than Facebook.
All right, there we go. Thank you guys for being awesome creative partners today, and we are Infinity. Thank you.